Over time, the structure of atom has been developed. So, starting off with a person called Democritus. Does anyone know who Democritus was?
Greek.
Hmm?
He was Greek.
Yeah, he was a Greek philosopher, and he presented this theory in very earlier times. He was there in 400 BC, and he proposed that everything is made up of very tiny and small particles. At that time, he didn't knew that these were atoms, and he didn't name them, but he stated that all matter is composed of tiny particles. All right. So at that time, he called it atomos. Atomos is a word which is used in Greek for small particles. And then we basically reduce the word atomos to atoms, and now we call them atoms. All right. With the passage of time, when things got more advanced and researchers and different scientists started working on the atom and its structure, then basically it was defined at that stage. But in the time of Democritus, he uh, only gave a hypothesis. He just said it. All right. Because at that time Democritus was in 400 BC, and there was no advancement and no technology which he could use, and he could you say he could validate that everything is made up of smaller particles. But his thinking, his mind, his ideology was this. He basically proposed his ideology to the people of that time, that everything is made up of very small particles. All right. So he didn't put up any experiment. He was not able, because he was not able at that time. The labs, they were not available, and there was no source of you see experimenting and validating this fact that everything is made up of atoms. But with the passage of time, people get to know about it after advancement in technology and learning. All right. So Democritus, yes, atoms were small particles that were different from each other in sizes and shapes. So again, I'm saying that this was his ideology, right? He didn't experimented and proved it. It was only his ideology that everything is made up of small particles. Then the very first person who uh, investigated about atoms was John Dalton. All right. John Dalton was the person who, even John Dalton, at the time of John Dalton, uh, he didn't knew that atom is made up of some subatomic particles. This structure of atom, which we know now, which we know today in the recent time, it has been developed over time by many scientists who worked upon this. Now, if you can see this timeline, which is in front of my screen, Democritus was in 400 BC, and he said that atom is tiny, hard, and uncuttable, means indivisible. And he didn't define a shape of an atom because he didn't knew because he was not able to see that whether his theory is correct or not. Then in 1803, John Dalton was a scientist who started investigating on the structure of atom, and at that time he was only able to see the external structure of atom, and he was able to uh, tell that atom is just like a ball. All right. Even John Dalton was not able to see the internal structure of atom. He said that it is an indivisible sphere. All right. And we cannot reconstruct it, or we cannot destroy it as well. Till the time of John Dalton, he didn't knew that atom consists of some subatomic particles, and those subatomic particles are electrons and protons. All right. It came into being gradually. Then in 1897, J.J. Thomson was a scientist. He conducted an experiment which was a gold foil experiment, in which he used a beam of electrons, and he just you can say cross that beam across an aluminium foil, a gold foil, sorry. And when he passed it across the gold foil, he observed uh, some behaviors of atom, the structure of atom. And that behavior was this: that when whenever he used to pass the beam across atom, that beam used to deflect at a certain angle. ओके मीन्स दैट जब भी वो अपनी जो बीम थी, जो वो बीम यूज कर रहा था, वो पॉजिटिव पार्टिकल्स की बीम थी, और जब वो क्रॉस करवाता था उसको गोल्ड फॉइल में से, तो वो किसी न किसी तरफ टिल्ट हो जाती थी, मुड़ जाती थी बीम। ठीक है। इससे उसने ये डिड्यूस किया, ये कंक्लूड किया कि atom is not just a ball, it has charges. Okay. Sometimes the beam used to deflect towards the ball, and sometimes it used to deflect away from the ball, from the structure of atom actually. And this was happening because of the electrons and protons which reside inside the structure of atom. So in spite of this fact, he came to know that the atom, it contains some positive charge and some negative charge. But still, J.J. Thomson didn't knew the exact position, the exact location of these charges. All right. He just said that there is positive and negative charge inside the structure of atom. As you can see, this round ball, it just shows some positive charges and some negative charges. My audio is off. My audio is not turned off. Maybe Dua, your audio is turned off. That's why you are not able to hear me. Okay, so J.J. Thomson, he concluded that atom consists of positive and negative charges. John Dalton didn't told that atom has any charge, but he proposed the structure of atom, which was theoretically correct because he saw it under microscopes. Okay, then another scientist, Rutherford, he came into being, and Ernest Rutherford in 1909, he concluded that uh, the positive charge is in the center. He basically conducted an experiment, and that experiment, does exact experiment of Rutherford, is present in your books as well. He conducted an experiment, and he after the as a result of that experiment, he concluded that uh, the structure of atom is defined. Okay, it has a central portion which is positively charged, and the negative charges are around that positive charge in a cloud form. Okay, even at that time of Rutherford, he didn't knew that there are shells present. Okay, then 1913, Niels Bohr, he was a scientist. He basically proposed the exact structure of atom which we use at this time as well. He told that electrons are negatively charged particles, and they surround the nucleus and they circle the nucleus of the atom in specific orbits, and he called those orbits as shells. All right, as you can see on my screen, these are circles in which the specific electrons they are moving, and in the center there is a ball which is actually called the nucleus. All right, and the nucleus, it contains protons, and protons are positively charged. So basically, the basic structure of atom is this, that it contains a nucleus. Central part is known as the nucleus, and the nucleus is composed of protons, which are positively charged particles, and neutrons, which are neutral particles. They don't have any charge on their surface. And the electrons are negatively charged particles which orbit the nucleus. Okay. Even Niels Bohr, he was a scientist in 1913. He didn't deduce the presence of neutrons. Till the times of Niels Bohr, they knew that there is negative charge and there is positive charge. But then, after Bohr, there was a scientist. His name was Chadwick, and Chadwick actually claimed this fact that the nucleus of the atom, it consists of an a particle which is neither positively charged nor negatively charged. All right, so this is basically the proposed model of Dalton. He thought that they were just solid balls. Thomson, he told that the atom consists of positive and negative charges. This is the experiment which J.J. Thomson he conducted. He used a cathode ray tube experiment. In this tube, he basically shooted positive particles on an atom, and as a result, the positive particles they deflected on either side. And as a result of that deflection, he came to know that there are positive and negative charges inside the atom, because at the time of J.J. Thomson, they didn't knew that what is inside this structure of atom. So they were curious to know about that what will happen if we uh, shoot something across the atom. So when he shot it, he came to know that mostly the structure of atom is empty and it has some charges inside it. All right, this is the experiment which Thomson he created. See, now he from the slit he is shooting the beam of positive particles, and that beam you can see that it is being deflected towards a positive plate and towards a negative plate. Why it deflected towards positive or negative side of the plate? Because there are some particles, because atom has some positive particles and some negative particles. The negative particles were attracted to the positive plate, while the positive particles, they were deflected away from the positive plate. All right, they were attracted to the negative plate. So charged plates deflected stream of particles, and he reasoned that there was charge component inside the atom. This is the conclusion of J.J. Thomson. And the model which he presented is known as plum pudding model. He said he didn't basically said that there are specific regions where electrons or protons might be available inside the atom. He just said that they are scattered in the structure of atom. All right. Then Rutherford, he used a gold foil experiment to further investigate the results of J.J. Thomson. All right, they went straight, so without deflection. So basically, Thomson, he crossed in. He just used the uh, negative and positive plates to see that whether the atoms, they will be attracted to negative or positive side or not. But Rutherford, he shot across the atom and saw that whether they will be whether they will going to pass across the atom or they will be deflected to any side. This is a difference between the experiment of Rutherford and experiment of Thomson. Thomson used cathode ray experiment, and Rutherford's experiment is known as gold foil experiment. All right, this is how he deflected some subatomic particles were deflected over here, and he used a radioactive source in which Rutherford, he shot some positive particles only in this gold foil, and he saw that most of the particles, they went through the gold foil while some were deflected to the positive and negative sides. As a result, he said that there is then he particularly aimed to shoot the beam in the center, and when he shoot the beam in the center, it was deflected. So this is how he came to know that there are some positive charges in center. Most of the structure of atom is empty, and there are some negative charges which surround the nucleus. All right. Then Niels Bohr was a scientist. He uh, proposed that electrons are specifically present in shells. They are not outside the shells. Then Schrödinger was a scientist. He said that the electrons, they can be found in a specific region, not only the shell. All right. So the current model which we are actually using of structure of atom is this, that electron can be found in a most likely region. All right, and which is around the nucleus, and this nucleus, it contains positive and neutral charges. The reason for the neutral charge inside the structure of nucleus is that it stabilizes the structure of atom. Neutral charge. Okay. There are Then Chadwick was the person who identified the and discovered the existence of neutrons, which are neutral particles. Okay, so in today's Neopod lesson, we have Bisma here, Abiha, Aisha, Dua, Fatma, Server, and Fatma Ahmed, Haika, Huda, and Ummehani. So let's start with today's lesson. So the code of Neopod's today lesson is SRZBF. I'd like everyone to join using this code. Okay, so the essential question before we start off with today's lesson, I'd like you to answer this question, that what is the basic relationship of the subatomic particles found in an atom? Today's learning objective is that by the end of this lesson, you'll be able to analyze the relationship between different subatomic particles that make up or construct an atom. Okay, so today we are going to go on a field trip to ancient Greek ruins. It was in ancient Greece where Greek philosopher Democritus first conceptualized the idea of the atom in the 5th century BC. Then we are going to do a virtual lab to explore the atomic structure, and we'll explain our observations as a class and extend our knowledge by comparing and contrasting different chemical elements. Alright, so let's start with today's lesson. Okay, so I'd like everyone to answer this question. The smallest component of matter is. Okay, so Haika, Ummehani, Bisma, Abiha, Huda, Fatma Server, Dua, Aisha Mekan, and Fatma Ahmed. Most of you have answered it correctly. That is B. Thank you for your participation in this question. Then I have another question for you. It is that define atom and write a statement about the relationship between atoms and matter. Let's see your answers. Okay, so Haika is saying that atom is the smallest particle of matter that can exist. The relationship between them is that matter is made up of atoms. That is correct. Ummehani is saying atom is indivisible particle which cannot be further divided. It contains electrons, neutrons and protons in form of positive and negative charges. You may correct it. It's in form of, okay? These charges add each other and made an atom. And matter is made up of different atoms. That is correct. Then Bisma, she's saying that atom is the smallest, tiniest particle. Democritus is a Greek philosopher and he discovered the atom, and relationship of an atom and matter is that matter is made up of atoms. Yes, exactly. Abiha is saying that atom is the smallest particle that cannot be further divided and it contains positive, negative and neutral charges. Matter is made up of atom. That is correct. Huda is saying that atom is the smallest particle which existed and the relationship is atom is made of matter. No, Huda, matter is made up of atoms, okay? Please correct this one. Then Fatma Server Dua, your answer is incomplete, my dear. Then Aisha is saying that atom is a small particle made up of matter that exists. Particle? Particle, it's my dear particle. Okay, so the relationship between them is matter is made up of matter. No, matter is made up of atoms. Okay, so make it correct. Alright, then Fatma Serva is saying that atoms are basic units of matter and defining structure of elements. That's correct. And the term atom comes from Greek word for indivisible because it was once thought that atoms were the smallest. Yes, it is also a fact that atoms are the smallest indivisible particles. Okay, so atoms are the smallest unit of matter. That's correct. This means that atoms are building blocks of all other substances. That is absolutely right. Okay, then Fatma Ahmed is saying that atom is the smallest particle to exist in everything. Correct. Matter is made up of atom and atom in the matter combine together chemically. Yes, that is correct as well. Okay, so thank you so much for your correct answers. Let's move forward. Alright, so we are going on a field trip to Athens. Let's see. Okay girls, so in this field trip you are going to actually view old Athens, and you are going to determine that what was the basic reason that Democritus was not able to do different experiments, okay, in order to validate his theory or hypothesis. Alright, now look, this is old Athens. Athens is a city in Greece. This is old Athens, the previous Athens. See, these are ruins. This is how it was in BC. No development, nothing except buildings, no technology. See, so it's evident that he could just give a hypothesis, but he could not investigate his hypothesis and give a proper experimented conclusion to his hypothesis. That why is he saying that? But because of their strong beliefs on science, they came up with these beliefs, and we now experiment on these beliefs and we investigate them further. Okay, so this is it. The virtual tour is ended. This is it. It was just a single angled view of Athens, ancient ruins. Now let's move forward to our next question. Alright, so while you were visiting the ruins, what thoughts did you have about why Democritus could not test his ideas about the atom? And why do you think we are able to study the atom? So let's see what are the answers which we have received. Haika is saying that I think Democritus could not test his ideas because of the lack of technology. And I think we are able to study the atom in modern, the spellings are wrong, world because of the advancement in technology. That is correct. Ummehani is saying Democritus was in ancient times and there were no labs. Exactly. And today we have modern tools. Bisma is saying that he couldn't test because everything was so backward. Yes, exactly. They didn't have any technology, while we do have. It's correct, Bisma. Abiha is saying that he couldn't test because of lack of technology. Yes, exactly. Huda is saying that because he didn't had resources and technology. Yes, the answer is right. Dua is saying that there were no machines or laboratories to do investigations. Yes, exactly. But it was not ruined, Dua. We see it that way now because it's such old buildings. Aisha is saying he could not test the ideas because in ancient time there were no modern items. Yes, exactly. Okay, Fatma Ahmad is saying that he could not test because in that time they did not have modern equipment. Yes, and Fatma, you are right on this fact that they had belief in science. Okay, I like this point, but you are saying that people did not had much belief in science. They did believed in science. That's why they gave different hypotheses. Okay, so it's a very good point arose by your side. Thank you for your answers. Now let's move to the next slide. Let's explore. Okay, so we are going to a virtual laboratory in which we'll see that how the structure of atom is designed. Alright, so here you are free to design your structure of atom. You can pick up these balls and arrange it over here. Let me do one for you. Now if I pick up one proton over here, put it there, one neutron in the center and one electron in the shell. See, it's hydrogen. Now if I add one more proton to it, it is going to become helium. And if I add a neutron, it will still remain a helium, and then if I add an electron, it will still remain a helium. But see, now here this is a neutral atom. If we remove an electron from here, it becomes a positive ion. Okay, and let's see what happens if we add an electron here, an excess electron, extra electron. Now see, it's a negative ion now. Okay, so let's see what we have learned from this. Now if you keep on adding protons, see, addition of protons leads to a changed identity of this specific atom. But change in number of electrons, it only changes the charge which is upon this atom. Okay, so as you will increase number of protons, it will change its entire identity. Now we'll move to the next question. Now what did you notice when you change the numbers of different subatomic particles? Basically, what is the conclusion? The conclusion which we can derive from this activity is that if you change the protons in the nucleus, it is going to change the identity of the atom. Okay, the structure of the atom will be changed, its identity will be changed, its properties will be changed. All right, and it will become a new element, another element. Okay, but if we change number of electrons, it only alters the charge on the surface of the atom, but it doesn't alter the identity of the specific atom. Okay, even change in number of neutron doesn't change the identity of the atom. It is the identity of the atom or the new element is created if we change the number of protons. By this we can also conclude that number of protons are distinct. Every element has a different number of proton number. Okay, so thank you so much for today's lesson. Now the time is up, so thanks for coming here, and we'll inshallah continue it in the next class.